6.3a. This is your next exponent rules video. And so the first set of rules you learned was the multiplication rule. When you multiply two bases that are the same, you add the exponents. We did the division rule. When you divide same bases that are the same, you subtract the exponents. We learned the rule of zero exponents. Anything raised to the power of 0 equals 1. And then you also know the rule. So anything raised to the power of 1 is just the base. So x to the first power is x. And then you know the negative exponent rule now, that you cannot have negative exponents. If an exponent is negative on top, you move it to the bottom, make it positive. If it's on bottom, you move it to the top, make it positive. So this is your next rule. This is the power rule. And we're going to talk about raising powers to powers. We're still doing the same goal. We're still trying to use laws of exponents to be able to simplify these. And so let's talk about the power rule. Now, before I get into the actual law itself, I want to show you what's happening, okay? So I have x squared to the third power. This means I have 3 x squareds. If I was to expand that, I could write that out and say I have x squared times x squared times x squared. I have 3 of these. That's what this says. And if I kept expanding this, this means I have 2 x's. And so does this. And so does this. So that give me x times x times x times x times x times x. Now, how many x's do I have there? I have 6, right? And so we don't want to have to keep expanding this down. That would take way too long. And so they came up with a rule that basically said there's got to be a shortcut, okay? And so the shortcut is that when you're raising a power to a power, in other words, I'm taking a base of x, raising it to the second power, then raising it to the third power, all you have to do is multiply the exponents. 2 times 3 gives you 6, right? So I could just skip all this expanding and just keep my base, multiply the exponents. So keep the x, multiply 2 times 3, you get 6. So that's the power rule. You're able to if you're raising a power to a power, multiply the exponents. All right, so let's look at some examples. So here we go. We got x squared third. This is one we just did. We would do keep the base, multiply the exponents, get x to the 6th power. Okay, the next one. This 3 belongs to everybody inside the parentheses. So we're going to have to put that 3 with the x squared and the y fifth. And so basically what that's saying is it's x squared to the third, y fifth to the third. So it's going to look like this, right? X squared to the third, y fifth to the third. Once again, you're going to keep the base, keep the x, multiply the exponents. Keep the base, multiply the exponents. Now, these are not same bases, so we're done, right? Next one, we've got 2 to the 4th power and a squared to the 4th power. That 4 goes to the 2 and the a squared. So what I'm going to get is 2 to the 4th power and a squared to the 4th power. Well, 2 to the 4th power equals 16. 2 times 2 times 2 times 2 is 16. And then you keep the base, multiply the exponents, you get a to the 8th. The next one is similar to the first one, except we have a negative, but that negative is on the inside. And so that's going to be a negative 2 to the 4th power. And it's going to matter because we're going to do a negative times a negative, which is a positive, times a negative would be a negative, times a negative would be a positive, okay? So negative 2 to the 4th power is 16, and then a squared to the 4th would be 2 times 4 is 8. So we're just applying these exponent rules. All right, they just get more complicated, but it's still the same rule. Now I want to make sure you understand what's happening here. So what's happening here is this 3 has to go to everybody on the inside. And so he has to go to everybody. Okay, so when I write this out, that 3 goes to the negative 4, it goes to the x squared, it goes to the 3, it goes to the y cubed. Then you want to take each one piece by piece. So I'm going to separate this out with imaginary lines so you can see what's happening. And so I'm going to have to do negative 4 to the 3rd power. Well, that's going to give you negative times a negative times a negative. Now remember, a negative times a negative times a negative. That's giving me a positive. And when I multiply a positive times a negative, I'm back at negative again. So an odd number is going to give you a negative. Even number is going to give you a positive again. So this gives me 4 times 4 times 4, which is 64. So I get negative 64. Keep the base of the x and multiply the exponents to get 6. And then 3 times 3 times 3 is 27. Keep the y, the base, multiply the exponents 3 times 3. And that's one more step. I've got negative 64 times 27. I can put those two numbers together and get negative 1728. So it's just simplifying this down using those laws of exponents. Now, it doesn't matter if you're multiplying or dividing. It's still the same thing. That 4 goes to the a squared, and that 4 also goes to the b third. And so that's going to give you this. It's going to be a squared to the 4th, b cubed to the 4th. You still multiply the exponents. So you're going to get a to the 8th. 2 times 4 is 8. And b to the 12th. 3 times 4 is 12. All right. They just get more complicated. It's still the same thing. Doesn't matter if they're negative exponents or not. And so that's 2's got to go to everybody. And so when you write it down, I always just write everything down because it just makes it easier. And so I'm going to get a4 squared. I'm going to multiply 4 times 2, get a to the 8. Then I got my b. It's negative 2 times 2 is negative 4. Then I've got my a on bottom. A, 2 times 2 is 4. When you look at this, there's several things going on. I got an a on top, a on bottom. I'm going to be dividing, and I got a negative exponent. So let's take care of the a's first. A to the 8 over a to the 4. You keep the base, subtract the exponent. You get a to the 4. And we still got b to the negative 4. And now you can't have a negative exponent. And so what I would do is drop that b to the 4 to the bottom, make it positive. And now we're done. All right, so I want you to pause the video. I want you to try to work this one. This one kind of encompasses everything we've been doing. And so go ahead and throw it in there. Let's simplify it down as far as we can. And then you can unpause and check your answer. So go ahead and pause. Okay, so now, if you paused and came back, this is what you should have done. The 3 goes to the 2, the x squared, the 3, the x cubed, and the y squared. So you should have got 2 to the 3rd, x squared to the 3rd, 3 to the 3rd, x cubed to the 3rd, y squared to the 3rd. And we got to clean this up, right? So I'm going to do this just step by step because it's kind of harder to see when I do it all at once. And so 2 to the 3rd power is 8. 2 times 2 is 4. 4 times 2 is 8. Keep your base. Multiply your exponents. 2 times 3 is 6. On bottom, 3 to the 3rd power. That's 3 times 3 is 9. 9 times 3 is 27. Then keep your base. Multiply your exponents. 3 times 3 is 9. Keep your base. Multiply your exponents. 2 times 3 is 6. Now, we got several things here. I'm going to do a little imaginary line so you can see what I'm doing. But I've got 8 over 27. Not a whole lot I can do about that. And then I've got these x's, right? And so I've got x6 over x9. So we're going to keep the base. 6 minus 9 would give me negative 3, right? When you divide same bases, you subtract the exponents. And the y6 is on bottom. Now, cannot have a negative exponent if we're going to drop them. So the 8 is going to stay on top. 27 is on bottom. The x to the negative 3 becomes x third on bottom. And then y6 stays on bottom. And then now, that's as far as I can go. Okay, so that is it for the power to power rule. If you have any questions, be sure that you attend tutorials so I can help you. And make sure you do your practice, your star checkout, and your ticket out the door.